on fine-tuning the large language models. I believe that cost of the GPU resources are not the most important factor. Why do I say that? Let me explain this to everyone, and by the end of the video, I'll share what we truly need to focus on. Now, let's conduct a cost analysis centered around fine-tuning models. The cost mainly consists of 4 parts, assuming we already have a clear problem to solve. The first cost is for the GPU used in fine-tuning. For GPU cost, it's quite easy to calculate. For example, if we want to fine-tune the 7B parameter llama model, we generally only need 1 GPU card. When fine-tuning, we often use efficient methods like LoRa. For larger models, like a 65B parameter llama, about 8 GPUs may suffice. Fine-tuning time typically ranges from hours to days. Based on current market rates, renting an A100 GPU costs around $3 to $6 per hour. Therefore, a complete fine-tuning session may cost from tens to hundreds of dollars or even up to a few thousand. Overall, GPU costs are manageable. The second cost is labor. For typical large model fine-tuning projects, 1 to 2 engineers should be sufficient. This cost is also easy to estimate. Then, there's inference cost. Once the model is deployed, inference cost will accumulate. However, we usually consider inference cost only after a product is successfully developed, at which point we try to minimize it. For now, we focus on creating a successful product and exclude inference costs for the time being. The final cost is data. Data collection costs are highly variable. If a company already has high-quality data, it can be formatted as instructions for fine-tuning, minimizing cost. If not, we may need to hire people to label data or even maintain a web scraping team. Overall, data collection costs are highly uncertain and closely tied to business needs. In extreme cases, data costs may exceed all other costs combined. This is a rough cost analysis of fine-tuning a model. Next, let's look at cost structure from another perspective. For a typical AI project, there are several stages. First, we need data. Once we have data, we train the model, then test it. Most AI projects require iterative cycles. For example, if testing shows poor results, we may revisit the training process, adjusting hyperparameters or methods. After extensive iterations, if issues persist, we may examine the data collection. Is it accurate, or do we need more data or better quality? If, after long iterations, the issue remains unsolved, we might reconsider the problem definition itself. Is the problem well-defined, or did we misjudge its difficulty relative to current technical capabilities? At this point, we may go back to the problem definition, then gather new data, train and test repeatedly. This process reveals which stages are crucial. The first is selecting the right problem. The second is choosing data appropriately for the problem. These 2 steps are closely linked to the business side. By handling them well, you can imagine the potential cost savings. Throughout this process, GPU cost is relatively insignificant. This is the main issue most companies face: significant spending with no results. Often, we are excited to tackle a problem but see no impact, simply because we did not invest enough time or attention in these 2 steps. The technological barrier is not as high as it seems. The true challenge is integrating technology with business needs. Especially as technology is constantly evolving, we must clarify which problems we aim to solve with current capabilities and align the product and technology roadmaps. These are my thoughts. If you have different views or questions to discuss, please leave a comment below.